Hello, this is Professor Michael Abbasi for Sinclair College, and I'm here to talk about Topic 12 for my CHIF or CIS 2808 forensics class based on the CHIF contents. And this is on cloud forensics. So at the time of this recording, this is Topic 12 in a 16-week syllabus, and it is Volume 3 of the CHFI EC Council Content Chapter 5. This is going to be a pretty quick video, not much to demo here. In fact, I think I have the lab set out where you actually just look at the lab documents. So, because there's a lot of moving parts and the lab has you do stuff with the cloud, I'd rather you look at the analysis of how to analyze the cloud versus actually working those cloud components. That would be later reserved for cloud-based classes. So, but again, this is Module 12 here. And as before, we talked about with analyzing servers, things like that. You need to understand the you know the underlying architecture. I think the last topic was database, and we talked about is to have some understanding about the underlying architecture. Excuse me, to help you identify where evidence might be held. And there's an important aspect here we look at, and this is the fact that how cloud is set up. And so this might be a review about what cloud is, but it's good to understand if you're approaching an evidence or a case, is it infrastructure as a service? Um, so in this case, it's almost going to be as we have servers, storage, network resources. So EC2, load balancers, Azure virtual machines. These are in essence full-on servers. So this is going to be more traditional to what would be like almost like investigating a data center on premises, where you have access to these components. However, it will change as you look at platform as a service. So you might only use software development tools, configuration management, and deployment platforms. So this is a higher level tier of this. So you might use SAP Cloud Platform, for example, things like that. As you approach this level, it's good to understand what the provider can offer you in help with resolving an incident. Let's click to click there. So, and then the highest level, of course, being software as a service. So we know this is eLearn, which I'm on right here. Of course, it actually runs on, I believe, on Amazon itself. Um, but these are cloud-based applications. So when you get higher up this tier here, in this case, further down the slide, it might be hard just to dig in and get those logs. But you can imagine they're not going to take Google Docs down because of a security incident. But however, they might freeze that account and be able to offer some evidence or some artifacts from that. So, and I'm going to say this again, it's probably one of the biggest ones here. It's going to be an example, logs. So look back at the log analysis. That's going to be a huge one, but they could offer, of course, a snapshot of a VM, or you might create your own snapshot, or you might get a database, which you would do database analysis with. So there's a lot of ifs here with the cloud. So again, understand the deployment also, not just the type of deployment, but how it's deployed. Um, Community cloud, public cloud, private cloud, and so on. Hybrid clouds was the one I want to bring up here. That's the one that might be some, and I say they show some private, some community, or some public. Think of private as on-prem or on-premise. It's not uncommon for some um, industries, some companies to still keep some computing in-house. Maybe they used to have their own data center and they're slowly migrating to the cloud. So understanding that virtual private connection and what is accessed in the cloud and what is accessed on-prem. So beyond that, which adds a lot of complexity already. You can imagine the moving things here. Of course, is just the threats, and this is going back to investigating web attacks, for example. Um, what was the attack under play here? And something to identify is example like DDoS attack. Now, if you have like Azure or Amazon or some other maybe Rackspace, they actually might have some sort of DDoS mitigation in play and might stop it for you and hopefully inform you. So they might be able to provide information from that. That's the idea behind the DDoS prevention is with cloud, you can have auto scaling. And that's something to bring up here. So no matter what cloud you use, I know auto scaling might be maybe a term used for AWS, but I think it's a generic enough term to bring up here. So In essence, maybe we have three web servers, web server 1, 2, and 3, and in front of that we have a load balancer. Um, what auto-scaling is actually intended for is this. Um, let's say we create a brand new, let's say load balancer does round robin algorithm. Load balancer is just, distributing the work between these three, and let's say there's some application servers behind it. And of course we have our database. So these are app servers. App server 1, app server 2. These of course can talk to those. Now, what auto scaling will do is you invent a brand new product, it comes out, it's the hottest thing ever. Your capacity is starting to increase. What it increases, we can actually scale up extra servers as needed. So you can and those get automatically add to the load balancing, and they'll automatically talk to the server. So here's the thing: as they scale up, and when they're not needed anymore, when things come back down, those of course can be removed. So that brings up a point about sort of the non-permanence of cloud architecture, and that's something important. So if the incident response says turn off the server, and let's say that used to be that was fair, an on-prem data center, you go there, you turn the server off. It's being attacked or something's going on, and the other server takes up the work. Well, you could possibly go in and turn off a server, but you actually might remove the server, which removes the entire server itself, which might include log files or other artifacts from an attack. So um, that's something to keep in mind. So that's something I've seen before. As companies move to the cloud, they need to rethink how they do incident response. So um, yeah, it's considered a subset of network forensics because network forensics deals with both private and public networks. Network forensics is going to be a huge deal. Understanding, again, not just if it's SaaS or AIS or platform as a service. Uh, these ones are going to have more restricted controls over the network monitoring and tools. So you need to lean on the company, the hosting provider, to help you with that. Again, and physical access is usually never really allowed. It's very restrictive on all platforms typically. So also understand what is you're investigating. This actually applies to, this actually came from I remember the CJS computer crime course. And this is something I should have brought up, I think, earlier on in this material, but how is the computer being used? Is it a subject of the crime? Hence, was someone in there hacking to steal identity of user accounts? Oh, he's always a huge one, right? We see that a lot. But is it an object of a crime? Hence, it's sort of a victim of the crime. Whereas you just want to take the entire thing down. I don't care what's on it. I just don't want to see it on. So hence DDoS falls into that. Or is it a tool of a crime? This is something else we got to think about. This is new with cloud, I think. Um, it's not new in general. I could use my laptop as a criminal to cause a crime, or my laptop could be part of a crime. So, but if a criminal, if they cover their tracks well, it might be hard to go back and find what you need. But there could be some evidence you can collect about someone fired up a cloud account and used that cloud server as a tool in a criminal activity. So that also is going to come in and play how you approach um, the case. So the architecture, how it's deployed, and then also how is it used, or is it so that's a really good slide. I like that one. So stakeholders in play here. It's a good one. I'm not going to go over all these slides in depth, but I just want to bring up these are the ones I bookmarked as I think good to look at. So back to stakeholders. So law enforcement, third parties. There's some stuff about cloud here we'll see, and I'll just drop a little spoiler alert. Residency of the cloud too. Where is it at? You know the fact that you know here we had a data center in this state or a person in this state. Let's call this our actual state in the United States here. They committed a crime to victim 1 and victim 2. They were caught. They have evidence. search and seizure for their home within the state, and so on. Maybe they cross state lines, and you can still get a warrant and work with other authorities. This is going to change a lot. Now you're dealing with the fact that this is not just within a state and a country. You might be dealing with other countries that have data centers. So really, really, my poor drawing there of a country. Um, but this is the fact that you're dealing now with worldwide issues here. Other governments might have restrictions on what you can get. And so this external assistance is one thing. It's going to be a tough one. So anyways, um, some challenges, deletion of the cloud. That's a big one. If someone just deletes the cloud instance, thinking that, well, that's what you do with the server's being hacked, we delete it. You just lost a bunch of artifacts that could be used. With something overwritten, also a possibility. And single point of failure, um, yeah, this is a good one. If the ecosystem has that, that will go back to like deletion. That could be a single point of failure. Um, Again, they can access clouds under, they can set up a fake account, use fake IDs, and set up a cloud instance. And not all cloud providers are going to monitor what's going out. So again, real-time investigation might not be possible. And then we could malicious code possibly hosted on a virtual machine. That means it needs to be containerized, it needs to be securely like compressed and then transported maybe on a separate device. Again, in multiple venues and geolocation, it's a huge one. Um, Chain of custody is going to come into play. How you do this, different jurisdiction issues. There's a lot of stuff there. So the guy in the cloud and so on. These are more things here. Aaron Cloud Management Portal Configuration, that's a huge one. Um, I just saw an article about like Microsoft had like 48 terabytes of data. Uh, Someone had left out in the cloud. There's a lot of things, and not all. The criminal goes in and just scoops it up. The configuration was incorrect. So sometimes it's not as hard for the criminal just to go find misconfigured servers, which if you take any of my other courses, that's an OWASP top 10. I think it's like number 5 or number 6. Um, the cloud can offer that, but people think clouds is secure. It's not. It's only as secure as you um, make it, almost like any other system. Chain of custody again. Um, it can be some really crazy stuff with chain of custody. And so again, a lot of times you're not going to have the entire server taken to you. You're going to get a snapshot of it if you're lucky. Maybe this is a log. So, and again, data location. Might be hard to isolate or image the virtual machine. With a platform as a service, infrastructure as a service, IaaS, that's not as bad. But if it's a software as a service, you're looking at, you really need to lean on the cloud provider. Can you offer me anything? And as a bunch of this case, you might need to bring in some sort of warrants if it's criminal. Search and seizure might not be as easy as you think. So dynamic storage could be a problem. Live forensics might be a tough one unless you can do what the lab shows you. So, and there's some notes here about the lab I'll show. So I know I'm not going to spend a lot of time on these ones here. Log files, decentralization of logs. Let's go back to log analysis lesson. Same thing applies here, understanding the architecture and where logs are held. Luckily, a lot of times with cloud, sometimes you have logging servers in place or other areas, and that could be these right here. So CloudWatch, for example. So CloudWatch offers a service in AWS to track metrics. Also, so used for tracking all kinds of metrics, but also can be used to help you in a case. So the logs from CloudWatch would be very valuable, and these could be put off into a CloudWatch server. So again, we have like a logging service. Azure has something, they have their Azure Monitor. So very same thing, you might be able to get an idea, a snapshot of who talks to who. You can find some tracing. You can get extensive details. Think about having this level of monitoring with cloud, which a lot of times makes it easy to set up versus a homegrown system. Is a Logstash output. I mean, you can have some great stuff here. We can get the data a lot of times from an issue by using these tools in the cloud. So it can be a double-edged sword. Okay, so does that make it less inventory value logs? Possibly, but I think that the cloud is a lot more. It's a lot larger now. Almost everyone's on the cloud. but the tradition of this is the log health of the company, and it's always taken, we meet the rules of miscibility for logs. It might be a little more of a gray area for evidence. So, of course, physical data collection, protection, and so on. So as we move through this here, I'm not going to spend too much time on the challenges. Jurisdictional, I talked about that already. That's definitely one. Legal challenges due to different jurisdiction guidelines, including other countries. That's international cloud services. That can really make things messy. So evidence correlation can be a little more challenged, especially if you're dealing with logs from different countries. That could have different formatting rules in place, different data, um, different rules on what data is logged. It could be over in Europe, they have stricter standards. You might have less data, maybe due to like GDPR, things like that. But basically, there's some more challenges here. So one of the biggest ones, of course, is follow a step-by-step response procedure. That's probably a huge one. And there is some stuff here. The chapter talks about microservices, which sort of goes along with the both platforms of service, infrastructure as a service. Um, so Google, for example, Google Docs might run under a microservice architecture. What that really means is you break down what would have been maybe a larger web server into smaller chunks. These microservices usually run in containers, which can be good because you might be able to get a copy of that container. However, that means there's more microservices in play. So, uh, and this is again a little quick video here, but you see the idea about the lab here. And this is the lab manual for the CHIF ebook here, and this of course is for the cloud. And this is one of the labs, and a lot of steps in this lab, but the biggest one is this: creating a snapshot. I just want to point that out. And that's usually something you would do. So this EC2 instance is a suspect. Maybe it was again. Maybe it was it was a victim of a crime. So it was used, in a crime. It was a database server. Again, you create the snapshot, and you can actually get that snapshot, and then you can use that without touching the original instance. That's the good thing about it. Now, something that's new to this though is you might increase costs. If I start creating extra snapshots as storage, as those snapshots are out there, if this is a customer, they might need to come into play. That could be an issue. Maybe you can get that snapshot off to look at it, but you can see here they basically create an EBS, so they get the volume, the elastic block storage copied and set up. And this allows you to go ahead and then open this later here, where we kept the original one off and we have our forensics copy of it, which we can turn on. And again, this allows you to run and investigate a copy of this. And then you can also isolate this so it doesn't have external network access, only local console access, for example. I say local console access, it's still network access, but it's not part of the production network. Like I pointed out, it's not part of the load balancer anymore. It's off on its own. So, but yeah, this lab's also going to walk you through. Probably the biggest one, of course, is examining Azure, but also just looking at same thing with Azure is going to be extracting the logs from this stuff. So, and I believe the lab does this too. It has you looking at Azure logs. Um, so again, some of these concepts are tied back to other things: log forensics, cloud, network forensics, server forensics. So I like to actually walk away from this. You see a lot of steps here with this lab. I like to walk away with the fact is this: it's more about think about the higher level challenges that the cloud introduces to um, to the forensics process. So definitely dig in, look at the labs. If in the future maybe that you actually need to do parts of the labs. I think at the time of this recording, I think I would just review the lab document and then go and then look at where certain aspects are where forensic steps were taken. Example, making a read-only copy. That's an example of or a snapshot that's read-only of the disk. So there's an example right there. So again, we're going to summarize it with that. I just want to talk about the high-level challenges. And that should wrap up this look at cloud forensics for CIS 2808. Thank you for watching.